Greetings, year 11s. We're going to continue on with our advanced trigonometry. We've got two questions to start us out with for today, and here are those two questions. They are questions that have come up on past exams. I do like the question on the left. It's a lovely show that question, and the question on the right is a little bit sneaky. So you go ahead and have a go at those, and I don't think I have enough room to do all the working out on here, so I'm going to pause the video and just write the answers down. All right? Go ahead and get started. All right, here are my answers. For the first question, there's a few things you need to look at. They tell us that AB is equal to AC, which means that the big triangle on the left is a isosceles triangle, so the base angles are both the same. I started by finding the angle on the right, which was 75 degrees, because of the tiny little triangle at the bottom where one of the angles was 15 and the other one was 90. And then I can go ahead and find the angle on the left, which was 60 degrees, because I know that the entire angle on the left is going to be 75. From there, I found the angle at the top, angle A, by using angles in a triangle, and then in green, they told me that BA is parallel to CD. So if I trace all of those, that must mean that those two angles are alternate angles. And then if angle A is 30, then angle X must also be 30. And for the second question, I'm thinking of two numbers. If I multiply the first number by 4 and add the second number, the answer is 32. You can write that as an equation. You don't have to use X and Y. You can use A and B or any other letters. If I multiply the first number by 2 and add the second number, the answer is 23. That looks like 2x plus y is 23. And then you just go ahead and solve the simultaneous equations. So the first number is 4.5 and the second number is 14. All right, here we go. That is just our starter. Let's get ready for today's lesson. So today we're going to be looking at the cosine rule. The cosine rule is another bit of trigonometry that we use when we have non-right angled triangles. So I was telling you before that when we use the sine rule, we use that when we have two pairs of matching sides and angles. There's a different rule for when we use the cosine rule, and I will explain that as well. The plan for today is everyone should be able to know the cosine rule and be able to write it down. They used to give it to you in the front of the GCSE exam paper, but they no longer do. They don't give it to you in A-level, and you do also need it in A-level maths. Hopefully we'll be able to use the cosine rule to find a missing side length. And then we can also use the cosine rule along with the sine rule to solve more complex triangle problems. A lot of times they like to put both of these together in a question. So here we go. Let's start one of these questions. So the cosine rule can only be used when you know two sides and the contained angle. So two sides and the angle between them. So for instance, if I knew side B and side A, I could only use the cosine rule to find side C if I had this angle that was between the two sides that I know. So I would need to have B and A and angle C. So you always need to have the two sides and the angle in between them. Okay, the cosine rule, all three of these look basically the same, and they are. The cosine rule is A squared. So if you're looking to find side A, we would say A squared is equal to B squared plus C squared minus 2 lots of B times by C times by the cosine of angle A. So angle A would be the angle that is between the two sides. So I'm going to show you how I would label my triangle in just a moment, but hopefully you have written down this top one that has the red box around it and maybe drawn a diagram of the triangle in your book as well. All right, I'm going to go ahead and try one of these questions for you, so let's get it going. All right, example 1 is really lovely laid out for us. You'll see why in a moment. It says find the length of BC. So they want us to find out how long is this side over here. And if we look at the triangle, that blue side is exactly opposite to angle A. So I can call this little side A. So they'd like me to find little side A. Now, as you can see, I have two sides and the angle, which is right in between those two sides. So I can go ahead and use the cosine rule. So I'm looking to find side A in this particular question, so I can use that very first cosine rule as it was written out. So we've got A squared is equal to B squared plus C squared minus 2 lots of b times by c times by the cosine of angle A. Now, because we're squaring and adding them together, it really doesn't matter which order these are in, but if we're doing this mathematically properly, this side over here should be side B because it's opposite to angle B, and this side over here should be side C because it's opposite to angle C. But it doesn't actually make any difference because all we're going to do is square them and add them or multiply them and take them away. So it doesn't actually make a difference to which order we do this in. Now that we've labeled everything, all we have to do is go ahead and substitute everything into this nice long expression. So because we're not just looking to find a, we're looking to find a squared at the moment, I would try to make sure that I start my calculation by saying a squared, because we're trying to find a at the end of all of this, so we need to start by telling them that we're finding a squared, because we're going to take the square root, and we just don't want to be mathematically incorrect. So then we've got b squared, so 3 squared, plus c squared, so 5 squared, minus 2 lots of, I'm going to put them in brackets, 3 times by 5 times by the cosine of angle A, which is 43 degrees. So let's go ahead and type that into our calculator. If you're watching this video, I'd really hope that you're also trying to type this into your calculator at the same time as me, because we really want to make sure that we're all getting the exact same answers. So we go ahead and type that into our calculator. In my Casio calculator, I haven't done anything fancy at all. I haven't added any extra brackets. Instead of putting the brackets around the 3 and 5, I just wrote times by. And when I do that, I end up with a squared is equal to 12.059. You can do as many decimals as you would like at this point. And then obviously we're looking to just find a, so we need to go ahead and take the square root of that, which is why I was saying at the start of the question that you should write down a squared, not just equals. I'm going to go ahead and take the square root of the answer, and I end up with side A is actually equal to 3.47. All right, now I don't really think this picture is drawn accurately, but it does seem to give you a good idea of what this actually looks like. That side doesn't really look longer than the 3 centimeter side, but it looks like it could probably be about 3.5 centimeters. All right, that was our first example on that. Like I said, this triangle was labeled really nicely for that. I'm going to show you another one where it's not labeled quite as nicely, and I'm going to show you how I get around that. All right? All right, here we go. Example 2. Same idea, but different letters. I'm going to show you how I get around the letters this time. So find the length of D to F. So D to F is this side over here. I always think it's easiest if we want to call the side that we're looking for side A. That means that this angle over here is also going to be capital A. The easiest thing I think to do is just change the letters of the triangle. No one's really going to care. I think it's easier to change the letters of the triangle than change the letters of the formula. But that's my personal opinion. And like I said in the previous example, it doesn't matter which of these is in which order. So I'm going to call little b and little c. Because you have to memorize this formula, it's good to try to write it out as many times as possible. So I do like to start by writing out the formula so that I don't have to try to remember it as I'm going, and then it just becomes a substitution problem. So again, I'm looking to find a squared, so I'm looking for 7 squared plus 4 squared minus 2 times 7 times 4 times by the cosine of 46. Now, if you're feeling particularly fancy, you can actually do a is equal to the square root of whatever answer you get when you chuck all of this into your calculator, but it just depends on how fancy you're feeling. I think I'm feeling fancy. The square root of 7 squared plus 4 squared minus 2 times 7 times 4 times the cosine of 46, and close the bracket, and I end up with, oh, I did it wrong. It's okay. I ended up with a is equal to 5.1087. I just square rooted everything all in one go. So let's square that. And we get 26.0991. All right, there we go. I think I have one more example for you to try to make this even fancier, but other than that, that is pretty much us done. All right, let's try one more fancy example. All right, last example. I skipped example 3 because it was really boring. You can have a go at it, and we can talk about the answer on the Google Classroom. So this one's our fancy example, and it says, find angle X to Y to W. So they would like us to find this angle in here. Normally, when we do this kind of question, normally when we find an angle up until now, we've been using the sine rule, and we would be looking to have two pairs of sides and angles, but we don't have that. This blue angle goes with this 7 centimeters, which is great. But my problem is the 8 centimeters doesn't actually have an angle to go with there. And then the 65 degrees doesn't have a side to go with, which is really, really unfortunate. Thankfully, we can use the cosine rule to actually find this length over here. So that would be my first suggestion. I'm going to call it side A. I'm going to use the cosine rule to find that. So if that's side A, then this is angle A. And then once I've got side A, I'll have side A in the 65 degrees, and then I'll be able to use the 7 centimeters to help me find angle Y. Here we go. Let's do it real quick. So we've got A squared is equal to B squared plus C squared minus 2 lots of BC cosine A. Fill in what we know. Let's see how fancy I can be. A is equal to the square root of 8 squared plus 7 squared minus 2 lots of 8 times by 7 times by the cosine of 65. So I've put the square root in, so I don't need my squared anymore, and I'm going to do it all in one go. So 8 squared plus 7 squared minus 2 times 8 times 7 times the cosine of 65. Close my bracket. Hope I didn't have clumsy thumbsies. And A is equal to 8.1. All right, now that I've got that, now I need to use my sine rule. So I'm going to use my 8.1 over here. So I've got the 65 and the 8.1, and I also have the 7 centimeters and angle Y. So this time I'm looking to find an angle using the sine rule. So I'm going to put my sine of angle Y on the top of my fraction. So for this next part, I'd be looking for sine Y. I don't know why I wrote it like that. Let me just fix that. Sine Y divided by 7 is equal to the sine of 65 degrees divided by 8.1. All right, and then I can go ahead and find angle Y is actually the sine inverse of 7 times by the sine of 65 divided by 8.1. Chuck all that in my calculator. Sine inverse of 8 times by fraction. Nope, not 8 at all. 7 times by fraction. Sine 65, close the bracket, divided by 8.1. All right, and from there, I've ended up with Y is equal to 51.56 degrees. Right, you could probably call it 52. You can round it however you would like. It doesn't really tell us anything about that. All right, and that is our fancy question, because obviously you can see that we have to use the cosine rule and also the sine rule. The blue writing for the cosine rule, I would say that's the absolute bare minimum amount of writing that you should be doing. If you'd like to put in that first line where it says the square root of 8 squared plus 7 squared, that is a good place to start if you don't want to do all of the working out. All right, as per usual, let me know if you have any questions at all, and I'll talk to you later. Bye.